So if everybody's just getting on, good evening. We are going to start our week 6 beginning beekeeper class. In my opinion, this is the most important week. This is the one that's going to talk about all the treatments to keep your bees alive. This class is the one where we kind of prep you for the last 5 weeks about getting all excited about beekeeping. And then this is the one where we scare you and tell you about all the dangers of it and how you can lose your hives overnight if you don't do the right things. But hopefully what you will learn tonight will help prevent that and will keep your bees alive. I see a lot of emails right now, a lot of Facebook sites that people are checking their hives and they're losing their bees, they're dead, and they cannot figure out why. This class tonight should help you alleviate a lot of those problems and help prevent that from happening. There's several questions to ask when you open up a hive and they're all dead, but I think after taking this class tonight, you'll have a much better understanding the importance of it. I do feel pretty good that our club does not have nearly some of the death losses that some of the other people I've seen out there. I think we do a good job of educating you guys and telling you what your options are and how to treat these guys and keep them alive. But I think after this class, you're gonna have a lot better understanding of this stuff. So this is actually chapter 8 in the book that would be called Honeybee Disorders, Parasites, and Nest Invaders. So we're gonna talk about keeping clean bees, basically disease-free, parasite-free, pest-free. We're going to break it down tonight and talk about all of these. So there's 4 pest management strategies when it comes to beekeeping. Number 1, you can do nothing at all. I don't think there's probably too many people out here tonight listening to this that can afford to do nothing and lose their bees. If you want to buy new bees every year and keep them for 10 months out of the year, then go right ahead, but it's going to be an expensive hobby for you. Number 2, you can reduce the numbers of pests. Number 3, reduce susceptibility of the hosts. And number 4, a combination of the last 2. So what these are saying is we can try to keep all the bad things away from the bees, and we can try to build our bees up to be resistant to all the bad things that are out there. You're never going to get 100% resistance, but there's things we can do management-wise, treatment-wise to help the bees get through this. So we're going to talk a little bit about integrated pest management, or IPM. So the chemicals have been used since 1940 in bee colonies for pest management. They started using terramycin for bacterial brood disease. Then in 1984, we had tracheal mites show up in bees. Then in 1987, Varroa mites showed up. Then in 1998, small hive beetle was widely detected. So man create pesticides to try to fight these pests to help their honeybees. The problem with that is ever since we've created these chemicals, our bee numbers have been falling. A lot of this, I think, was just because we didn't know the proper dosages. We were probably using too much and hurting the bees. But some of that was we weren't using the proper management as far as the right chemicals and stuff. And it's getting much, much better. But there's a threshold that's important, a couple different ones. One is the economic threshold. How much can you afford to treat your bees and still be worthwhile? You know, you can't have a hive that's worth a couple $100 and spend $500 in treating them every year. So the other one is the treatment threshold. How much treatment can you put into those hives where the bees are going to not be harming themselves? The action threshold. How much time you're going to use, when to use it, is it too late, is it too soon? So rather than just treating at the first sign of a problem, our objective as beekeepers is to keep the pest levels below the treatment threshold. A lot of things we're going to talk about is being proactive and trying to ward it off before it's too late. So we're going to probably try to play a lot of defense here instead of offense. So maintaining a threshold is important. It's done by several different ways. One is a genetic host resistance. That is keeping your bees like a queen that is good at laying a lot of brood. The workers groom themselves a lot. They have resistance build up a little bit to the mites. Cultural practices that resist pests. There's a lot of different things out there, such as maybe you're using cedar boxes just as a deterrent from pests. Maybe you're using plants in your yard that are known that pests try to stay away from. There's a lot of things like that that we'll talk about tonight too. Beneficial organisms and parasites that prey upon pests. Sometimes we use organisms to, I know there's a nematode they use in the soil around beehives that's supposed to help prevent some of the beetles and stuff getting to the hives. So there's that option. And then hopefully chemicals are our last resort, depending on what we're using and trying to help. We talked a little bit about this in previous weeks, but culling older comb is very important. Recommend every 3 to 5 years replacing the comb, but don't do the whole hive at once. Make it a rotation, take 2 or 3 hive frames out each year. The reason for this is the comb is like a big wax sponge, and it's going to absorb a lot of the toxins, a lot of the chemicals, the pesticides that the bees are bringing back that they're picking up off the plants when they go out for forage and looking for honey, nectar, pollen. So they're going to bring that back to the hive, and that comb is actually going to be like a sponge and absorb the stuff that they're not intended on using. So by replacing that every year, you're kind of cleaning their home out for them and keeping those levels of chemicals down inside the hive itself. I recommend, we talked about in previous, probably week 2, about writing the year on the frame itself that you put that new frame in that hive. That way it's easier for you to look in there and say, oh, this hive was done, put in here 2 or 3 years ago. It's probably time to start rotating some of the frames out of there. You'll notice the frames, the comb itself will get darker each year. So when you have some hives or some frames that look black maybe, or dark brown, it's time to start rotating those out. It's going to dramatically reduce the buildup of diseases and maybe some spores. We'll talk about here in a little bit that you'll have a better understanding. The spores are going to build up inside that comb if you keep it in there year after year. The chemicals itself, and there's going to be other things too within that hive that the comb is just going to be a big sponge for. So with any animal, human, any type of disease, you have what is primary versus secondary. Most bee problems are secondary issues. Typically, I see people say, well, my bees starved to death, or it got too cold and my bees died. That might have been what finished them off, but that wasn't the initial problem. Chances are they probably had a mite issue that made them weak or susceptible, that maybe they couldn't eat enough honey to stay warm, or maybe they couldn't beat their wings fast enough to stay warm because of damages that occurred from the viruses that the mites carried. So usually the primary problem is a weak colony, but that weak colony is caused by an initial problem itself. So you kind of have to put your detective hat on and think about what is actually the original cause. It's easy to say, oh, we had cold weather this year, my bees died from cold weather. Well, that's not the case. Bees do not die from cold weather, provided they're healthy and have plenty of food. So I think sometimes we jump to the first thing that we can think of, and it may not be the primary problem. So different things that the weak colony could be caused by, might be a poor queen, could be Varroa mites, could be lack of food, could be other diseases too. So what I did was we broke this down into several different sections tonight to make it a little bit easier. The first ones that we're going to talk about are diseases of the brood. So when we're talking about brood, we're talking about the larvae that is capped off inside the cells. These are not adult bees that we're going to be talking about right now. These are basically bees or larvae that is inside the cells before they are hatched to an adult bee. So American foul brood is probably historically the most damaging of these diseases. It's restricted to brood, but the adults are part of the cycle. So you're going to see it called AFB probably from now on, just a shortened version, American foul brood. but it's why we have state inspections today. We have a state apiarist that will go around, they will come to your site, they will inspect your hives and look for diseases. This all got started when American foul brood came to the United States and devastated a lot of the hives years ago. The cycle starts when the larvae ingest spores that's in contaminated food. These spores germinate into an active vegetative state and they multiply. Anytime you're talking spores, it doesn't matter if it's in the foul brood or spores of a plant, spores multiply very, very quickly. It then penetrates the gut wall of the larvae and invades the body tissue. So basically it's eaten like from the inside out. So then the immature bee dies off after the cell's been capped off. So now you have this larvae it's not a full grown bee yet. It's inside the cell that's been capped off and it dies. So then you have this dead brood and it has a chocolate brown color because of its being dead. And the smell of it is kind of a sulfur smell or a chicken house smell. And that's where it gets its name, the American foul brood. So there's a European foul brood we'll talk about next, but the American foul brood has a sulfur smell. It smells like a chicken smell. That's why they call it foul, and it's brood. Bacterial brood disease is it's bacteria. It's a highly contagious. The spores can live for decades, and this is why it's important when we talk about making sure if you're going to buy used equipment that you have it inspected. Because you can look at some frames that maybe you're buying from a buddy and it looks to the average person like it's just regular comb, but there can be spores in there that maybe they haven't had bees for 10 years or so. Those spores, once they're around a living tissue and larvae, they can go ahead and continue their cycle and cause a lot of problems. So this is where we warn people to make sure you have your equipment inspected. Even if you're buying nukes, make sure those nukes come from a place that's had their hives inspected, because you're bringing frames, 5 frames in that nuke to your bee yard. The inspection spreads quickly through the hive, through the apiary from one hive to another, and on from there. It's assisted by bees and beekeepers because we're the ones that usually move them around, making splits, making nukes, whatever. So that's why it gets spread so easily. So here is a picture of American foul brood. You're going to see the sunken caps. Up in here, you can see how it's kind of dented in. The larvae's died off and those caps have sunken down. You might see some perforated cappings, like they've cut the edge out, but nothing came out of them because they're dead. The easy way to tell American foul brood is called the ropey test. You take a small stick or toothpick, stick it inside that cell, twirl it around, and when you pull it out, it's going to have a stringy rope-looking appearance to it. It's really, really thick mucus, and you're just going to have a smell to it, and you're going to know right away it's American foul brood. This is kind of a blown up version of an extreme case that shows the scale or the pores that can be around there that live on the edge of the cells and can be there for a long time. Usually you're going to have kind of a shot pattern because some of the larvae may go ahead and hatch out into adult bees, but most of them are going to die off. So you're not getting this nice, clean, open cells. You're going to have a few that are filled with dead larvae and a few that actually hatched out. So, and you may see some black scales in there as well. But when you see this kind of a shotgun pattern of randomly open cells, you might want to take a closer look and see what you're dealing with. As far as treatment goes, there's not a really good treatment. I have seen guys that would remove the bees, get rid of the comb, put them in fresh comb or fresh hives. But typically when it gets that bad, you're looking at probably destroying the comb and the hive itself. removing the bees, or sometimes even killing the bees too. So when it gets really bad, there's just not a real good solution to that situation. The management, as far as management, you absolutely want no threshold. As soon as you start seeing this, get that comb out of there, get it away from the rest of your hives. But you want a zero tolerance if you start seeing any of that early detection. Finding it early is the best prevention. The sooner you get it cleaned up, the better you're off you're going to be. You can recover from American foul brood, but it's best if you can catch it early. Some antibiotics that have been used is terramycin and Thailand. The problem is usually it's too late by the time you found it to treat them with that. This is probably where they're going to take all the bees, and obviously you're not going to shake them into another hive because that would just transport the spores too. But you would probably shake the hives off into the grass somewhere, let the bees go back to a different hive that's got new foundation, maybe not any comb at all, and then treat those bees that go back in there with some terramycin or Thailand. So, and then you want to do that in the springtime before you put your supers on, obviously. The best thing is prevention. Nowadays, our queens are pretty hygienic. They're cleaning themselves. The worker bees are going to throw out any bees that look like they're not quite healthy. So having queens that are having those genetics selected for hygienic behavior is the best. So those hygienic behaviors may be being able to detect abnormal cells of brood, uncapping them and removing them. The bees are doing the dirty work for you there. It's a generic trait that works for American foul brood, European foul brood, CHALKBROOD. We'll talk about those later. Even Varroa mites, small hive beetles. Hygienic behavior, you're going to hear quite a bit tonight. The good thing is most of this has been done for you because of years and years of selective breeding of these queens. We've built up a bee that's kind of resistant to some of this stuff, or has the characteristics of trying to prevent the stuff themselves. Sanitary hive handling practices. This is something that's probably most people are guilty of and don't even realize it. That could be maybe you have a hive tool that you use on all your hives, and then you go to your buddy's place and you help him out and you use your hive tool there. You could actually be spreading some of those spores from hive to hive. It's a real good idea to, even from your own hives, wipe down that hive tool really good before going and opening up your next hive. But especially if you go to or come from a buddy where you're helping them at their hives. Inspect any used equipment. Get a state inspector to look at it if you don't know what to look for yourself. Another thing is not feeding honey. And typically I say, if you're going to feed honey back to the hive it came from, obviously that's not an issue, but if you're getting honey from somewhere else, be careful of that. The question is here, what do you clean your hive tool with? It probably wouldn't hurt to have a bottle of bleach water and just kind of dip it in, or even just a wet rag or something just to wipe those spores off if they would happen to be on there. But you don't want to overdo it with any chemical or something and then use that on your hives either. So good question though. I'll do some more checking to see what they recommend, but anything just to maybe be as simple as only use a hive tool on your property. If you go somewhere else, let them use their hive tool and not bring yours with you or something. But back to not feeding honey. Like I said, if it comes from that hive, it's okay to feed it back. I know that happens sometimes. Or if you have, maybe you have a hive die out in the winter and you want to get rid of those combs of honey, you can feed it to the one right next to you, but don't bring it in from somewhere else. Yeah, number 2 up here is supposed to be genetic. It's not generic. Sorry about that. If that's the only spelling error you find today, then I'll be impressed because I probably have several on here. Cool. So now we're going to switch to European foul brood. Some of this is similar with a few differences, but it is very similar to American foul brood, but not quite as devastating. So when the bee larvae is infected with the bacteria, it causes the larvae to become very hungry. Normally, the nurse bees will throw out this larvae because basically when it comes to bees, everybody gets their fair share. Everybody has to work. There is no welfare when it comes to beekeeping. So if somebody's wanting too much food, they know something's up, they're probably going to get hauled out. So this is one of the genetic ways that the bees are taking care of the problem for you. The nurse bees will throw out that larvae, and that will eliminate your problem really quick. In strong colonies where there's plenty of food and plenty of nurse bees that they feed the larvae, that's probably when you're going to start coming to see in this situation, because they're not worried about the food quite as much. When the nurse bees switch back to foraging bees, the larvae dies from lack of individual attention, and so they're usually self-limited. So one way or another, it usually corrects itself, so it's not quite as the big problem as American foul brood. So here's this slide I put up here, just kind of a difference between, you got American foul brood here, European foul brood over here. So the stages of death, usually after capped with American foul brood, like we talked about, where you have the sunken caps. But in European foul brood, it's going to happen before they even cap it, so they can haul them out right away. Color, it's usually a chocolate brown to a black in American foul brood, and usually an off-white or yellow gray in a European. The ropey test works for the American foul brood, probably not going to work for the European one. You're going to have the sulfur smell in American foul brood, and might be a little sour or no smell to the American foul brood. Scales in the American, and they might be rubbery and probably easy to move in the European one. So CHALKBROOD. CHALKBROOD is caused by a fungus. It's got fungal spores that are ingested by the larvae. The spores are cooled in the gut of the larvae, and then they germinate. The spores compete for food. If the larvae dies, then the spore invades the body. So the larvae turns dull white, hardens, and looks like a piece of chalk. So this is what CHALKBROOD looks like. It's going to look like somebody shoved a piece of chalk in there and broke it off, because that is the larvae that died, and basically the fungus just took it over. As far as management, you can requeen with resistant or hygienic stock. Take care not to spread the spores between the hives again. Move hives to a less damp location. It needs that fungus needs the moisture to survive. You can usually use Apiguard. It's not highly infective, and outbreaks are rare. I've had bees for 10 years, and I have not seen any of these three problems in any of my hives. So with good management and keeping things clean, it's usually not a problem you're going to have. As far as prevention for CHALKBROOD, we talked about hygienic queens, sanitary hive handling practices there again, inspect used equipment. A lot of these are going to be just kind of reruns of the foul brood. Keep away from damp, moist places where the fungi thrives. Hive ventilation is important there again because of the moisture issue. Removing and replacing brood comb frames. If you're keeping your comb every 2 to 3 years, going through that and saying, okay, it's been 3 years old, I need to start rotating, put some fresh comb in there, you're going to eliminate some of these problems automatically. The next one is Sacbrood. It's caused by a virus. It makes the larvae look very flaccid, watery, and kind of resembles a Chinese slipper. Hygienic queens there again usually resolve this. If the disease occurs, you replace the queen. Relatively minor problem, and that is the end of the brood diseases. So now we get into the diseases of the adults. The good thing about what we've already covered is your chances, if you use good management practices, you have good hygienic queens, and you aren't sharing a bunch of equipment or buying used equipment, chances are you're not going to have a big issue with those problems of the brood. So diseases of the adults themselves, Nosema. This is a disease of the adult bees. It infects the gut. Again, it's caused by a spore that enters the adult and causes the bee not to act right. It makes her lifespan shorten, reduces the brood food, just starts really taking effect on the bees themselves. As far as management, well-selected wintering sites, keeping wintering preparations and strong hives. So making sure they got plenty of food, trying to keep them out of as much wind as you can, making sure the hives are strong going into fall and that they're healthy. And a lot of times Nosema is not a big issue. You can do some sampling or microscopy under a microscope to determine the infection. Fumigen bee, you'll see this in a lot of bee books. A lot of places that sell bee equipment will carry this. It's an antibiotic. It doesn't kill the spores. You mix it in the syrup, and then when the honey flow is absent, obviously there again, you never use a treatment when you have your honey supers on, but you put that in the syrup to treat, and it's just kind of an antibiotic that helps them get better. How you're going to know if you have Nosema is you're going to see a lot of bee poop on the outside of your hive. You're going to see bees wandering around on the ground out in front of the hive like they're lost. It's called K-wing. And what happens is it's kind of a birth defect that, or not a birth defect, but it causes the wings to be in this K formation or look like a K, and they can't fly normal. So they basically make it out the front door and they fall down and they can't get back up. It's due to, also you'll notice a slow spring buildup. Your bees just aren't really taking off and doing good. And then we talked about the fecal stains on front of the hive. Now, the one thing I want to make sure you guys understand is if you go out to your hives right now and you look at a lot of your hives, you're probably going to see this. This can also be normal depending on the year. This year we had a very cold snap and a long cold snap where the bees just were not able to go out, do their cleansing flights for them to go out and go to the bathroom. So what they would do, especially I noticed in some of my cases, they would go to the top entrance, kind of peek out, go to the bathroom and go right back in. So you'll see this in the springtime sometimes on the front of your hives. Now, if you start seeing this midsummer when it's plenty warm out and the bees should be flying anything over 50 and you're seeing constant buildup of this, then you probably need to do some more look at your hives a little closer and see if you've got a bunch of bees on the front of your hives down here in the grass walking around that can't make it back up to the hive, and look real close to see if you see that K-wing. Then you probably have Nosema. Rose, go ahead.
Okay, when you look at this slide, if it was pulled up, it almost looks, if you looked at it, compared it to what you would see now on the front of your hive, this looks like diarrhea. And what you're going to see on your hive right now is a more formed fecal spot. And that's the best way I can describe it. This literally looks like a diarrhea, and that's what immediately makes you think of a gut problem. And I don't know any other way to describe it other than that.
Yeah, that's a good point. The Nosema is going to be, like you said, kind of a watery, long stain where right now you're just going to see big chunks of poop out there on front of your hive. So, but yeah, it's pretty obvious when you see the difference. And like I said, you shouldn't be seeing this midsummer or anytime when they're out flying good weather. So just don't panic. I don't want people going out there right now and looking at say, oh my gosh, I got Nosema, and that's not the case. So here's another picture of it. It just looks really nasty. And you'll even see it on the bottom board some. If you looked under a microscope, it'd look like this. You're going to see, obviously, we're not going to be probably looking under microscopes ourselves, but for the, like, sent off to a lab somewhere, they would be able to detect this. But for what you're going to see with the naked eye is basically a really messy looking hive. Other viruses, they do exist. There's a bunch of them. You can have chronic bee paralysis, cashmere bee viruses, deformed wing viruses. Since they're a virus, there's just really not much you can do as far as treatment. I couldn't even tell you what symptoms are or any of these. I've never seen them. I just know that they do exist, and I wanted to point them out there to you. As far as prevention, what you do need to know, there again, changing the brood comb, making that rotation every 3 to 5 years if you can. Keeping your queens relatively young, not letting them be getting old and becoming weak, making sure they got good hygienic properties to them. Control the mites. And I would say right now, the theme of the whole night is going to be mites. If you control your mites, 90% of your problems are going to be eliminated right there. And we'll talk probably really in depth on that here in just a few minutes. Anything to keep your colony strong, whether maybe they need a little supplement, especially right now, just anything you can do to help them is going to help with that prevention. So now we come to the spotlight of the night, and we're going to be discussing parasitic mites. What a lot of people don't realize is we really focus on the Varroa. That is the one that causes a lot of the problems, but there are other mites that we need to discuss tonight first before we get to the Varroa. So the first one is a tracheal mite. This actually caused the Honeybee Act of 1922, which closed the borders for bee imports in the United States. I think it's still closed, to tell you the truth. But for the next 83 years at least, it closed it. They arrived in the US in 1984. They closed it trying to keep them out, but they still made it in. It's worse in colder climates, yay for us. It is a microscopic mite that lives in the breathing tube of the adult bee. The mite travels from bee to bee by the hairs on the bee. So it's not going to jump off them and go to the next one. It's going to crawl from hair to hair. Once the bee enters the tracheal tube, it feeds off the bee's blood. Sounds like a horror movie. So 25% or greater of bees infected in the fall is considered damaging. Infected bees are incapable of forming clusters and may form small clusters or crawl in grass incapable of flying. So what this is going to mean is we've discussed in several weeks here about how the bees will cluster tight and move their wing muscles to create heat to stay warm in the winter. If they're unable to form these clusters, they're going to get cold. Or if they form several small clusters, they're not going to be able to generate the heat to keep them all alive either. So that's one of the things that causes the tracheal mites to be deadly. At this stage, the colony will die and the hive will be empty. As far as treatments, they have a pelletized menthol crystal they can put on the top of brood combs. MiteAway 2 strips, we'll mention those again later when we talk about the Varroa mites. It's an absorbent pad with formic acid. Extender patty, it's a mixture of vegetable oil and powdered sugar. You mix the two together to form a texture of kind of like cake frosting. When the bees eat the mixture, they get covered with oil, which serves as a behavioral disruptant to the mites. So whether that oil is on the bee or going through the tracheal tube, the mites can't hold on. There's no chemical this way, and it's not harmful to the environment because it's all natural. And you can apply this method spring or fall, the mixture of vegetable oil and powdered sugar. The more you increase your young bees, such as doing a split, getting those nurse bees and stuff, the better off you are as far as treatments for tracheal mites. And this is a microscopic blown up view of a tracheal tube of a bee, and then you can see these mites attached to the inside of it. So I'm sure that's nothing fun for a bee to have that crawling around inside their trachea. Now we come to the highlight of the night, the Varroa mite. And this is actually a Varroa mite that is on an adult honeybee. And we'll be showing some other pictures of these. But this is, if nothing else, if you listen to nothing else on this presentation, This, for the next 20 minutes, will be the most crucial thing you ever learn about beekeeping. So, first of all, a Varroa mite is the most damaging pest of the Western honeybee. It started in the Eastern honeybee, where it was limited to drone brood. And this being limited to drone brood is very important to understand. We'll talk more about this later. But man brought the Western honeybee to the Eastern Asia, and that's when the mite jumped from the Eastern to the Western honeybees. So on the Western honeybee, the mite affects worker brood as well as drone brood. So when it was just in the Eastern honeybee and only got in the drone brood, they was able to basically put some drone cells in there, drone frames with comb, and let the mites go in that drone brood and then pull it out and get rid of them and keep the mite levels down. But now that it's going into the worker brood in the Western honeybees, the treatment's going to be totally different. Today, it's found almost everywhere bees exist, except for Australia and a few islands. This slide's probably 2 or 3 years old already, so that could have changed by now even too. I'm not even sure. There's been huge research done on the Varroa in the last 40 years. It's caused a lot of chemicals to be used on bees. Some probably were used before laws were created for them. Now there's some laws that create for them, but good or bad, we've done a lot of things trying to kill or control the Varroa mite. I will tell you right now, don't ever have the expectancy that you are going to get rid of 100% of the mites in a hive. That's just not feasible. I tell people you need to learn to live with them and control them at a management point that the bees can tolerate them, but you will probably never get rid of them 100%. They can be seen by the naked eye, just like the picture I showed you at the beginning here. It parasitizes both the adult and the brood, so they can actually start eating on either one. So what I'm going to show you here, if this works, just bear with me here a little bit. I'm kind of new to this, all this fancy technology and Zoom and videos. But what I want to share with you is a little video that is basically a cartoon that does a way better job of telling you what the bees, or how the Varroa affects the bees, what their life cycle is, where they come from, how they multiply, and how they affect the bees. So we'll watch this and then we'll get back here to this video. Oh. Just a second here. It works better if I do it right. And Rose, give me a thumbs up when I start this so you guys can hear and see everything.
We'd like to introduce you to the Varroa mite. Well, to be precise, we'd like to introduce you to millions of Varroa mites. Why so many? Well, when it comes to the Varroa mite, there's no such thing as just one. And if you'd like to see how an infestation starts,
Rose, you're going to have
you
to
need
chat
to look no
with me
further
on this.
than your own
see
bees, especially drones, as they're pretty social and like to travel between hives. Since Varroa mites don't have any wings of their own, they slip into hives by hitching a ride on the backs of adult bees. And for the lucky mite, the trip includes an in-flight meal, as Varroa mites will begin feeding on honeybees' fat body tissue within a few minutes of clinging to the bee. Once they've entered the hive, Varroa mites slip undetected into the vulnerable, uncapped brood cells. This is where the mites lay in wait until the bees cap the brood. Once a cell is capped, the mother mite, like a tiny spider, climbs atop the cocoon of the developing bee, tears open a hole, and begins to feed on its fat body tissue. Within 3 days, the mother mite lays her first egg, which always develops into a male. Then, she lays one female egg every 30 hours over the next week or so in her newly acquired home under the brood cap. And as each of these female mites mature, they mate with their brother. By the time the baby bee develops and leaves its infested cell, as many as 3 fertilized mites will emerge with it, and the cycle continues. Using this strategy, the Varroa mite population can grow as fast as the bee population it feeds on. But when summer ends and the bee population declines, the hive is left with a huge mite population, and that's dangerous. Too many mites in a hive will overwhelm and kill entire bee colonies. So what does that mean for everyone's favorite insect, the honeybee. Well, honeybee colonies with heavy mite infestations can't effectively pollinate or produce honey because they suffer from diseases and viruses transmitted by the mites. In fact, honeybees suffer from as many as 20 different mite-induced viruses, including the devastating deformed wing virus, which prevents them from flying. If you want to give your honeybees a fighting chance against Varroa mites, it's time to introduce your bees to Nod's organic mite treatments. To learn more about Nod's certified organic Varroa mite treatments, visit our website at nodglobal.com. Connect with Nod and beekeepers around the world by following us on Twitter, Facebook, and Instagram.
That is a really educational video that, in all honesty, if you have a chance to watch it again, when we get to the point where we're treating for mites in the fall, watch it again, because it helps you understand their life cycle so that when you're looking for mites in the fall, you know what you're looking for and you have a better understanding of what to do to treat them.
Okay, so I get back on track here. So like she said, that is one of the best little videos I've seen that describes it better than I could. You kind of get an idea how fast they can multiply. And as your population of bees are dropping in the fall, because they know winter's coming on, they don't want to feed everybody, so the population dies out and gets to a level they can maintain through winter. The mites aren't doing that. They're increasing until they eventually take over. So we need to talk a little bit about the mite life cycle, which was talked about in the video a little bit. So now you'll have a better understanding. The female Varroa enters an open cell of brood. The bee larvae is capped, and this transforms into a prepupal stage. The mite moves onto the abdomen of the prepupa. The mite chews into the skin and lays eggs. One son and several daughters emerge, mature, and mate. The original mite site keeps the site open so the young can feed. The bees, if the bee survives when it emerges from the cell, along with the mated daughter mites, and they disperse and then renew the cycle. So that's just one bee comes out, and about 3 females mated come with it. And I forget what it is, how many cells are on one frame. But when you have that many bees being born constantly, you can see how when one bee comes out with 3 mites, and take that times however many cells were on one frame of brood, the mite levels triple really quick every time one bee comes out. So the bee, if it survives, is greatly compromised. The bee's life is shortened. With widespread contagion, a colony can crumble very quickly. Mite population is worse in the fall. There again, because we said they are continually going up while the bee numbers are going down. As far as detection, some things you're going to see, your hives are going to either be less in numbers or empty hives. You might actually see the Varroa on the bees themselves. A couple things you can do is take a sticky sheet, place it at the bottom screen bottom board. They make these that slide underneath the screen bottom board. The mites will fall off and get stuck on the sheet. And then after 3 days, you come back after placing that, you can count the mites that are on there. A lot of people get caught up with the numbers, how many bees you're seeing. If you see mites on there, you're going to need to treat, bottom line. You can also physically count the mites that you see on some bees. There's the ether roll we're going to talk about, granulated sugar roll. All these are ways that you can actually physically count the numbers, and we'll talk about them in detail here in just a second. So just some more pictures. These are the mites that are on a bee that wasn't quite mature enough to hatch out of the cell. This is a cross section of comb with larvae that's been capped off. It's brood, it's capped. They have not emerged yet. And you can see all of the mites that are in those cells. So that is why it's so important to be able to have to control these mites, because you can see how quick they can take over and how much damage they cause. So these are ways that you can find out how many mites you have in your hive. One way is called the ether roll. It's a quick and dirty sampling method. You need about 300 bees, which is about a cup of bees. If you take just a kitchen cup, measuring cup, go out and you want to try to get nurse bees, because the reason you want nurse bees are they are the ones that are going to be taking care of the brood, that are going to be closest to where the mites are. So find a frame with brood, take your measuring cup, scoop up about 300 bees or so, put them in the jar, give them a shot of ether. I've heard people use windshield washer fluid because it's got alcohol in it. Regardless, you're going to use ether or something that's going to kill the bees. You're going to sacrifice these bees to do an ether roll to count how many mites you have. You're going to shake and roll the jar, and as you roll it, the mites are going to come dislodge and stick to the sides of the jar. So here the guy is. He's got his bees in here, about an inch or so thickness of the bees. He's spraying it with ether. They're rolling it. And then you're going to see these little mites stuck to the side of this jar. There again, you know, obviously this is a high count. There's a lot of bees or a lot of mites in that jar right there. They're definitely going to have to treat. The one thing I guess I can't stress enough is if you do a mite count and you don't find any mites at all, I would probably do another one. I just don't think there's very many hives, especially in the Midwest, that does not have any mites at all. And in my opinion, it's better just to, you're probably to treat them and be safe than to miss them on your counts and lose your bees later. So different ways of treatment. We'll go into all these detailed. The integrated pest management, that's talking about having you can have a screen bottom board that hopefully the mites fall through there onto a sticky board or something. You do that every 4 weeks just to make it harder for the mites to climb back up into the hive. Hygienic queen, genetic host resistance. So the Russian bees are supposedly better at grooming themselves and picking the mites off. Used, you know, all of these by themselves is not going to be a successful treatment for Varroa mites. But if you use all these together, it's going to help. The idea here is you're going to have a Russian bees cleaning themselves. The mites fall off, fall through the screen, can't get back up in the hive. Use drone tapping. That's where you insert drone foundation. The mites seem to be more prone to going in the drone foundation, but they will go into the worker foundation too. Once it's filled, you take the drone brood out, freeze it, or there's one that's way you can even electrocute them, and that kills the brood, which causes the mites to die out. You put it back in there, and the bees will clean it out. So you've taken away the cycle of what the mites had to be to survive. You can also dust them with powdered sugar. You remove all the frames in the brood and dust both sides with powdered sugar. The bees start grooming themselves frantically, trying to dislodge. Let's see. They start grooming themselves, trying to remove the dust of the powdered sugar off of them, and this will actually dislodge the mites off the bees, is what it is. There again, you'd want a screen bottom board for the mites to fall down through there. So all of these are instances that will help, but by themselves are not going to be a full plan. And even if you do all these, there's still, your chances are you're still going to have a pretty large mite count. Okay, I had a question here. It says, I read an article about propolis as a major preventive of antibiotic and antimicrobial properties. Any thoughts in fight against Varroa and tracheal mites? Yes, propolis is an antibacterial, but it will not do very little for preventing Varroa mites. It's going to be more for the bacteria problems that you're going to have, and not such as far as pest control management. So it does have its role, but not for mites. So when we start talking about chemicals and pesticides, I know a lot of people kind of don't like to hear those names and don't like to use that stuff, but I think once you get a better handle on what they're used, how they're used, you'll not quite feel so bad about it. Some of the chemicals are synthetic, nerve poison. Some of the brands are Apistan and Checkmite. There's a concentrated botanical oils, Apivar and Apiguard. There was a question earlier before class about essential oils. This kind of goes along with essential oils, but these are probably a little bit more stronger and geared toward what the mites do not like. So essential oils may have a place, but I don't think they're going to by themselves will be enough. There's other organic ingredients such as formic acid is in some of the products. I think it's sucroside. So different products that you can buy right now from any bee supply. One is Apiguard. These are little pouches that you pull the top off. And I don't go into details of each one because instructions are on those and they're actually changing them from time to time. So I'll show you the different products, but as far as the details of how many days you're supposed to be in the hive or whatever, read the label for that. But how this is worked is you would take this packet out, probably peel off this tin foil top and set that. It may set it on top of the frames and maybe in between them, and you leave it there for so many weeks. It may be one per deep, it may be one per hive. You have to read the product to find out. The one thing I want to stress is all of these treatments, anything with chemicals, you would not use once your supers are on, and until you took your supers off, then you could use them again. But you would never use any of these when your supers are on the hive. Hop guard, there again, it's a strip that you put down between the frames. It's the plastic is probably impregnated with some sort of chemical there that the bees would walk over. It would be harmless to the bees, but it will kill the mites. There's a MiteAway strips. There again, some of them you lay on top, some of them you put down in between there. Apivar, I use this one a lot. I think it recommends 2 per deep. This little tag, you flip up, put it down between the frames and put the tag over here so it doesn't go all the way to the bottom. The bees walk over it. They pick up what's on there and it gets rid of the mites. These usually are recommended so many weeks and then you take them out. But there again, read the package. Now, oxalic acid, this is kind of a newer one that's been used in the last several years. What oxalic acid actually is or was used for is wood bleach. So you can go to about any farm and home or box store and find wood bleach relatively cheap. It comes in kind of a crystal or powder form, and it has to be vaporized, and the vapor is actually what kills the mite. So you take a vaporizer, which is what this picture right here is, and all it is it's got a power source. It might be a plug-in that is AC, or it might be direct to a battery for DC, but it's powered by some sort of electrical means. And then there's usually a glow plug, just like you'd have for a diesel engine, that the electricity heats up this glow plug. You put a little scooper of oxalic acid in this aluminum pan, and that would vaporize. That's what would actually kill the mites. You want to read the instructions for times, because typically what you would do is you would put this in, you put your scoop of oxalic acid in this pan, slide it in the entrance, the front entrance, plug it in, you'd leave it on for 3 minutes, and then you'd shut it off for 2 minutes, and then you're going to leave it set in that hive for another 10 minutes for all those vapors to get through that hive. The one thing you really got to be careful of is this oxalic acid vapor is not something you want to inhale. You really should have a mask on. If you even get a whiff of the smell of that, you know it's not something you're going to sit there and smell, because it smells really, really bad. It's really strong, and it's not something that's healthy for you. Had a little bit of a fuzzy picture here, but it's a different type of a vaporizer. Same principle. It's got a heat source, a little pan. They put it in there. You'll slide this inside the front entrance. And usually what I use is a wet towel to completely close that off, so the bees can't get out while they're being treated. Let me back up here. A couple things I want to say about oxalic acid vaporizers is I get a lot of calls saying I treated my bees for mites and my bees are dead. The first question I'm going to ask is, what did you use for a treatment? They say, oh, well, I use oxalic acid. Okay, my next question is going to be, how many treatments did you give? Because oxalic acid treatments should be given in 3 treatments, and usually anywhere from a week to 10 days apart each treatment. The reason for that is the mites are inside capped brood. So when you stick this vaporizer in there and you vaporize this oxalic acid up through the hive, you're only going to kill the mites that are not inside of that brood. So you have to wait until that brood hatches out in order to kill the mites that are inside the brood that's capped. So if you do that every week for 3 weeks, you're going to have, by the time you start to the time you end, given the bees enough time to all have emerged and opened up and come out and expose those mites in that time. If you just do one treatment and you walk away and say, well, I treated my bees, you've got a lot of capped brood in there with mites in those cells that you didn't even touch. And I think this is one problem that gets a lot of people in trouble, is they're not fully treating their bees, but in their mind, they've treated them. The other situation I ask is how many weeks you treated your bees, and they say, well, I've treated them 3 weeks, 10 days apart. Great, perfect. Now, the next question is, at what time of day did you treat those bees? If you went out at 1 o'clock in the afternoon and stuck this vaporizer in that entrance, half of your bees were out foraging that probably had mites on them, or they brought mites back with them. So you may not have got a good kill on those mites. So there's a lot of factors involved as far as treatments and the effectiveness of that treatment. Personally, I like to pull my supers off about the 1st of August or mid-August at the latest. By the time the state fair comes around in Iowa, I hope to have my hives, supers all off my hives, and then I start treatment right after that. The nice thing about that is in August in Iowa, typically it's hot. So I know that come dark, all my bees are going to be in that hive. And that is a perfect time for me to go out about 10 o'clock at night. I'll shine my headlights on my hive. I'll use my battery on my vehicle to plug in my vaporizer. I'll seal off the front entrance with a wet towel. I'll stick that vaporizer in there. And I know probably 99% of my bees are in that hive because it's nighttime and they're not out foraging. That way I get a much better kill. So that is some of the things to think about when people say, oh, I treated my hive with oxalic acid and my bee still died. You know, they think it doesn't work. Chances are it's usually a human problem and not the chemical problem. I mentioned this, I don't use this. This is more usually for commercial beekeepers. I can't tell you much about it, but I know that they take the wood bleach or oxalic acid, they mix it up in a solution, and because they don't have time to stick a vaporizer in for 15 minutes per hive, what they're doing is a quick method where they're mixing it up and actually drizzling the oxalic acid in a solution over the top of the bees. I can't tell you personally, like I said, how good or not this works. I knew some of the commercial guys were using it. I don't think it worked quite as well as I originally thought, but if you hear of an acid drip, that's what they're talking about. Another good idea, regardless of what treatment you use, it's no different than if you're trying to deworm a bunch of cattle, it's good to change up your treatment just so the mites don't build up resistance to that product. If you're using Apivar year after year after year, mix it up a little bit. Use some MiteAway, use some oxalic acid, you know, for each year, use something different. That way you're changing it up and your mites are not going to get resistance. Like I said before, there's no silver bullet. There's not going to be one thing that works foolproof. I like to mix it up myself. When I pull my supers off in August, I like to use oxalic acid vaporizer because you get a quick knockdown of your mites right away. When you put a chemical treatment in there, it takes several weeks for those to actually get through the hive and for them to take effect. When I put my oxalic acid in there, boom, I knock my mite control down. And wait a week, more hatched out, boom, knock them down again. Do that for 3 treatments. After those 3 treatments, I know I probably got a pretty good kill, but now it's probably around the 1st of September and I still got all of October and November to get through. That's going to be relatively warm before winter hits. So what I'll do at that point is I'll use a second backup and I may stick some strips in, whether it's Apivar or something else that's going to last for several weeks. And I have a very good mite control going into the winter. Something else you have to think about is the bees that are going to survive the winter, they're going to live a little bit longer than the normal bee. The normal bee probably in the summertime is going to live about 30 days, and the winter bees are going to live a lot longer just because there's not going to be them going out and foraging and banging up themselves in the wings and everything. There's not going to be a lot of brood being hatched out in the winter, so those bees will live a little bit longer. But those bees are going to, that are surviving the winter, are going to be hatched early fall. Because when they're hatched as an egg, by the time they go through all the stages and come out as an adult, it's going to take them about a month. And so that you need to be thinking about mite control early in the season. The healthier your bees are in the fall, the much better, greater chance you have of them surviving through the whole winter. So any questions on mite control? I cannot stress how important this is. It's just something that you need to take serious if you want to have, if you're not going to treat your bees, then just go into it knowing that there's a highly likely chance they're going to die. I have people asking me about trying to genetically produce bees that are resistant, to build up resistance to mites without using chemicals. If you look at some of Tom Seeley's research, where 100 hives were used, it took about 4 years. In 4 years' time, they lost about 96 to 98 hives out of the 100 they started with, and only 2 or 3 built up resistance of the mites and lived the first 4 years. If you can afford those averages, that you can afford to buy 100 hives and get to them to be genetically resistant, more power to you, go for it. But if you want your hives to survive and you want to enjoy them and not have to buy new bees every year, take your mite treatment serious. Rose, is there anything else you want to add to that on the mites?
No, just make sure that you rotate. As you said, we don't want to build up resistance, because if we start getting mites, we're going to have huge problems. It's not that they're not coming out with new things, but we don't have anything as of recent that has proven to be able to treat mites. So whatever you choose wisely and make sure that you vary. And when we're all said and done, we'll get to my post that I put out tonight.
So I don't want by any means people thinking I know more than anybody else or more than you guys about beekeeping. I don't. I've made a lot of mistakes. I've lost a lot of hives over the years. I have figured out a lot of the things I did wrong. I was not big on mite treatment when I first got started. I did not know much about it. The first 2 years I taught this class, I knew nothing about oxalic acid. It's kind of really came on here in the last few years. But what I can tell you is now that I've taken it serious and I try to hit it early and I stay on top of it, I can tell you from personal experience this year where there was a lot of hives that were lost. I had 15 hives going into fall. I have 15 hives alive right now. Rose, you can speak for yourself, but I think you've had high success numbers this year too after taking it mite treatment serious.
I have. In the past few years, I have taken my mite treatments very seriously. And I want to say this, every beekeeper does things different. With that being said, I want you all to follow the instructions on your mite treatment. And then what I have learned is that when I started doing my mite treatments, what I like to do in the fall is I like to do either the Apivar strips or the MiteAway strips. And I put them in and then I leave them. And I do not pull them out until spring. And when I started doing that, I started going down to basically 0 losses through the winter. I still feed them heavy, and I still, in January or February, pop them open, check them, and give them more food if needed. So I know that I'm not having a loss from hunger. When I started leaving those mite strips in there, that took away my losses.
So another thing I didn't really talk about is typically everything we talked about tonight, we talked pretty much about fall treatment. That is probably the most important time to treat the mites because that's going to be their highest number of buildup. However, it does not hurt to go out right now and do a mite count and see what your levels are and maybe do a treatment before you put your supers on. Because once you put those supers on, your hands are tied at what you can do for treatment on mite control. I'll ask a little question right here and see how close you guys were listening. Why would you get a better kill this time of year using oxalic acid than you would in the fall? Does anybody have a good answer for that? It looks like I answered Dan's question before I even seen it because it says wants to know about treating in the spring. So that's what we're going to talk about real quick here. But why would you guys get better kill on mites using oxalic acid vapor in the spring versus in the fall? Anybody got an answer? Okay. Yep. Less bees or less brood and low bee count. Right. The thing is, you don't have hardly any brood right now because all winter long they've been cutting down on brood production because they don't want to make more bees because that's just more food they'd have to provide. So here between now and when the dandelions start blooming, they're not really going to start creating a lot of brood until they know there's a food supply coming on. So with that very little brood, there's very little few places for the mites to hide and be in capped cells. So by treating right now, you can get a really good kill with oxalic acid because they're not hiding in the cells. It also works pretty good to put the strips in right now because your size of your hive colony is going to be small and that cluster is going to be small. So it's going to work really well for all those bees to go over those strips in a short amount of time. So it does not hurt to treat them right now when the weather's nice and you're able to open your hives up and do that treatment prior to putting your supers on. So it's something that people don't think about in the springtime. Maybe your mite numbers aren't very high right now. but it's sure not going to hurt to treat them. So unless you guys have any other questions on mite control, go ahead and type in the questions there in the chat box, but we're going to move on. Nest scavengers. These are usually management error, and man, there's nothing more frustrating than opening up your hive and seeing some of these things that got out of control, especially when you know it's probably something you could have prevented. So the one thing that I just absolutely despise is wax moths. These things can destroy a hive really quickly. And this kind of goes back to what we talked about earlier on primary versus secondary. These are usually a secondary cause. The primary cause was probably a mite problem that made your numbers go down, or it could be any other disease that made your numbers go down. But when your population is low is when these things really take over. They're wax moths. What you're seeing, these little black spots, are probably the eggs. These are the larvae that have hatched out, and this is the adult. And what they do when they get to take over a hive, they called wax moths. They will go through your wax in your hive and your comb, and they will make tunnels. You'll see tunnels in a couple slides here, and they have this webbing, and it just absolutely destroys your comb, and it is a pain to clean up. I've had years ago when I didn't know what I was doing, I had one hive that's so bad I ended up burning the whole box. It was just completely covered in this stuff, and I knew I was never going to get rid of all those little eggs. But the other thing you have to watch out for is when you pull your supers off after you extracted your honey, you store those frames somewhere. And if you don't have some sort of a treatment prevention for wax moths, they love dark areas. If you just stack them up in a shed somewhere and don't pay any attention to them, that is a prime spot that these wax moths will get into and take over. You can see some of these eggs here close, the webbing in between the frames. There's a larvae, or it used to be where a larvae was. It looks like it hatched out. But this is a tunnel that goes through the cells. And when you start seeing this, this is usually the first sign you'll notice, is that you got waxworms there. Question was, if I use oxalic acid in spring, how long do you wait till you put on your supers? Oh, I'd probably give it a week or two. Yep. These are wax moths, and they will line up, the larvae cells will line up one after another, and it's just a mess. Even with a putty knife, these things are sticky and hard to get off. So as far as management and prevention, the stronger and healthier your colonies are, the less problems you're ever going to have with wax moths. It's when they start getting weak is when you start having problems. It's also mainly a stored equipment issue. If you can store them in an airtight container, such as maybe a tote that you tape off the edges, maybe put your frames in a freezer. I've had people say they stored their frames in airtight containers. When they open them up, they're full of wax moths. That's because there's eggs in there that you carried in there when that was put away. So if you can freeze them first and then store them away somewhere in an airtight container, that's one way of doing it. What I do is I stack mine in a shed. I'll put a paper plate down at the very bottom, and I will put paramoth. Do not get this confused with mothballs used for clothing and stuff. Mothballs can be harmful to your bees. This is paramoth. What it is basically like little crystals or powder. Once you put that out into the air, it turns into kind of a fume or vapor, and it goes up through there, and it makes kind of has a mothball smell, but it'll keep the wax moths away, and then you can store your containers the rest of the year. I usually do 1 or 2 treatments throughout the year just to make sure I don't get those into my supers that I pulled off with all my comb. Small hive beetle, there again, it's an opportunist that's going to take over when there's a weak colony. It's a secondary system. We talked about that before, only in weak colonies. you're probably going to open up a hive and see a few small hive beetles. That doesn't scare me. If your population of bees is good and you're just not seeing a whole bunch of them, that's when it becomes an issue. They can cause a slime over the honeycombs. I've seen problems when the bottom board wasn't tilted enough that it actually collected moisture instead of letting the moisture run out. I had a guy one time where his was tilted back. It had rained, the moisture got settled in the back of the bottom board. That moisture was a perfect place for these hive beetles to take over, and they killed that colony in about a month's time and forced them to leave. Checking for small hive beetle, the easy way to do it is to take your outer cover, put it upside down on the ground, and then when you're going through your frames, you're going to see these guys scurrying around, and they may fall down on that box. But when you pick a frame up, you may see a little black hive beetle running around. Like I said, if you see one or two, no big deal. But when you've seen a bunch of them, then maybe you need to do something about it. This is what they will look like when they take over the larvae. It looks like a bunch of maggots. They're slimy. It's just a nasty, nasty thing to have to clean up. As far as control, keeping your strong colonies healthy, you can use mite strips, nematodes like we talked about earlier as a natural prevention. They put that in the soil around the front of the hive, supposedly help keeps the hive beetles away. They do make a beetle trap. It's just a little tray that you put in between your frames. Usually you fill them with a little bit of vegetable oil. It's got openings that the beetles can get down in, but the bees can't, and they fall in that oil and they can't get back out. Anytime you have like especially right now, something to consider, guys, if you've got honeybees that have died out because of the winter, if you leave those boxes unattended between now and to the time the bees start being shipped out and you buy new bees to put in those boxes, that is going to be an opportune time for those hives to be taken over by either wax moths or small hive beetle. So be careful of that. You may want to go through them, clean them out. You may want to even put them in some place that you can keep an eye on them closer. But unattended hives like that with that wax in there, that wax is just an attractive for those type of pests. Some people even store, going back to the wax moths, some people will store their supers on their side so that the sun can actually penetrate down between the frames during the daytime. The wax moths do not like that sunlight being able to go down through there. They like it dark. So that's another way you can store your hives. Here's just more pictures. These small hive beetle larvae taking over. You can see that slime, they're attracted to that moisture. It's just a mess. We kind of went through a lot of this. Store your dry comb. We talked about exposure to light, the better the ventilation. The paramoth again, you can use that. You can freeze them. Cold storage. The nice thing about Iowa is typically if you run some paramoth in the fall, when you first store your supers, once you keep those bugs out and then it turns cold, those moths and those small hive beetles are not going to be out prowling around when we have our cold weather. So usually you have to worry about it prior to being cold and then warm up in the spring. So keep an eye on that stuff. Here's an example of a small hive beetle trap. Like I said, that plastic tray, they can go down there where the vegetable oil is. The bees can't get in there and the small hive beetles can't get out. So we'll talk just a little bit about colony collapse disorder. You don't hear much about it as now as you used to. I kind of think a lot of the reason for that is some of the colony collapse disorder was probably being blamed for colony collapse when it might have been Varroa mites as well. But basically it was just where you went out there one day and all your bees were healthy, and then you come back and then there's just, your bees are gone. You don't have hardly any adult bees in there. Your stores of honey and bee bread, they had plenty of food. There's evidence of recent brood rearing, meaning the queen has probably laid eggs pretty recently. You might even have a queen and some bees still present. and then even the pests really are probably slower than normal, but all of a sudden, basically, for some reason, your bees just vanished. That is pretty much what colony collapse disorder is. Nobody really knows what the causes of it is. There's been several theories, but it's just all of a sudden your bees are gone. It's first recognized in the fall of 2006. Just basically disappearance of the majority of the bees, yet the queen and the honey remain. There's no single known cause for it. Researchers think it's the stress is one factor. It drives them out. There's been all theories about cell phones, power lines and stuff, just myths. The one thing I really want you to think about is pesticide use. We're going to talk about the good and the bad of this. Obviously, as beekeepers, if we're using any sort of Varroa mite treatments, chances are we're using a little bit of pesticides ourselves. Pesticides can be good and bad depending on how they're used. This neonicotinoids, it's a class of chemicals found in recently developed pesticides. They've already been outlawed in most of Europe, in France, but there's a growing push to have these outlawed. The European unions have really had most of these outlawed over there, but they are very damaging to bees. Another thing that's been talked about with colony collapse is malnutrition. Some domesticated honeybees are only pollinating a few crops throughout the year because we force them to these areas and to pollinate the almond trees. I kind of use an example of, we take probably 50% of the bees in the United States to California every year to pollinate the almond trees. Imagine what would happen if we took 50% of the cattle in the United States and corralled them into one location for 3 or 4 months out of the year, exposed them to all the different things that they had, sicknesses and diseases, and then took them all back to their original places and spread that disease. That's kind of one thing that doesn't help. And then also I talked about monocropping, forcing them to live off of one plant. It'd be basically like giving us one type of food and telling us we had to live off that for 6 months. But we also have to remember, as beekeepers, we are farmers. We often move hives from different locations. Scientists theorize that this excessive moving results in rapid seasonal change and colony stress, confuses the honeybees, makes them more susceptible to disease. I don't care if it's a person or animal or a plant, anything that causes stress makes them more susceptible to sickness. Excuse me. So this is just something I put together. It kind of gives you something to think about. 1984, we talked about the introduction of Tracheal Mites. We talked about 87, the Varroa mite showed up. 1998, small hive beetle. So what does man do? He creates a pesticide to fight all these pests. Thinking we can always cure everything, we make a man-made chemical and we're going to kill all these pests that are killing our bees. Then in 1990, Bayer, who was one of the largest chemical companies, start creating neonicotinoids. As of 1999, this, whatever you call it, I can't even pronounce that word, it's the most widely used insecticide in the world. It can be found in Bayer Advanced Garden, Tree, Shrub Insect Control, Advanced Fruit, Citrus and Vegetable Insect Control, Ortho, Max Tree, Shrub Insect Control. All these different products contain this product, which is one of the neonicotinoids. Then in 2006, we start seeing colony collapse disorder. Then 2011, Bayer realizes something's up, so they create the Bee Care Center, trying to figure out what's going on. May of 2013, the European unions banned the neonicotinoid use in Europe. So Bayer, BASF, and Syngenta, 3 of the major chemical producers, they sue the European unions trying to get this changed. last I knew, in 2016, Maryland was the first state to ban neonicotinoids. I do not know of any other state right now that has went ahead and done that. So keeping this timeline in mind, especially 2013, where Europe banned that use of that insecticide. If you look at this slide, this is the total number of bee colonies that are stable in Europe. And this is by the 15 to 16 million beehives. And if you look at about 2013, when they banned the Europeans banned that use of that pesticide, how they jumped up. Especially if you look at Europe here that had that growth, and Asia had the biggest growth of anything. Kind of makes you wonder how much those neonicotinoids really did hurt the bees. Something else I just kind of threw together, China ranks the #1 in the world for annual pesticide consumption, and the United States is second. And you look down here, I don't see maybe Italy, France, only a couple of the European nations are in there, but if you look how much higher we are in pesticide consumption, we cannot be doing our bees any good. So living with pesticides, we are not going to get these banned in the United States anytime soon. We have such a strong farming economy, so we have to learn to live with this. But things you can do, I'm not trying to scare you to death on this, saying that all your bees are going to die from pesticides, because they won't. But be smart about it. One thing you can do is the Iowa Department of Agriculture and Land Stewardship provide you a way of registering your hive locations so that any commercial applicator has to, prior to spraying an area, I believe it's, they usually look at it once a week to see where those hives are located. That does not mean that they cannot spray next to your property. It means that they can only spray during certain times of the day when your bees are not likely to be out in the fields. But it's up to you to register your hives, and you need to do this yearly because it expires every year. You have to renew it every year. I just renewed mine last week. So you can go on to the Iowa Department of Agriculture and Land Stewardship, and you can click on, I think it's Bee Check or Field Watch, and register your hives. This is a picture of my page. And I just kind of use this as an example. I have 4 different sites where I have beehives. These are my sites, my locations, and it also lists any beehive anywhere else in the county or the state, actually. So I can click up here in Osceola, and I know where there's one of my beehives about right here. I know the person that has it down the road. I know the people here in this area. And then I have another hive here. I have another hive actually right here, 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 and here are my hives. But it's kind of neat to see how many beekeepers are out there, how many are registered, and how much area we're actually starting to protect for our bees. So it's not just my little circle, you know, it's the other circles that start building up and really protecting the areas. Other things you can do, excuse me, to avoid accidental exposure to pesticides is where you place your beehives. You know, the bees are going to fly anywhere from 1 to 3 miles to go get nectar and pollen. So if you put them right on the field edge where you know they're going to spray, then you're just asking for problems. You can register them in the sensitive crop directory. And this is actually a picture of Rose from her house when her boy was littler. And this is when one of the crop planes spraying over the top of her house, or the field next to her house. What I want to point out here is not to panic every time you see, whether it's an airplane or a farmer spraying a field. First of all, there's a lot of things they spray and put on crops that aren't pesticides. They may be a herbicide, they may be a fungicide, they may be fertilizer. So don't panic as soon as you see that. They may be doing something that's not going to affect your bees at all. So just one of the things we wanted to point out to you guys, that we can live with this pesticide issue, just being smart about it and how we do it. Rose, is anything you want to say about this picture?
Most of the people that are doing the crop dusting are not spraying pesticides. It's mainly they're either dropping nitrogen or they're doing fungicides. So, you know, you guys have to stop and think about it. I'm a farmer. My husband's been a farmer his whole entire life. That is how we make a living. We are not going to go out and put something on our crops that we know is going to damage it, because we also need the bees to go out and do their job. So, you know, we are just as conscious about it as what beekeepers are. So don't panic when you see the planes, and just make sure that you guys have your hives registered. Scott called me this week and said, hey, you haven't registered your hives yet this year. Well, he's right. And of course he looked and seen that I wasn't on there because I haven't done it yet this year. So get your hives registered.
Couple things, and correct me if I'm wrong, Rose. First of all, you know, corn's self-pollinating, but soybeans require a pollinator to really have the production in soybeans. So the farmers are not going to do anything to hurt the bees and the pollinators because they need them for their crop production. Second of all, it's kind of my understanding, most pesticides that are used systemically in the seed, so that they're not being sprayed foliar and on top of the leaves and stuff. So they're usually a systemic application versus a sprayed application. Is that correct?
Correct. Most of your seed corn that you're buying is stacked with traits that naturally are in the genetically modified into the plant.
You know, it's so much easier to control the pesticide that way than to try to spray it and let the air take it and stuff. So that's why I don't get concerned about sprayers anymore, because with science, they've improved the technology and the way they apply them and everything. So chances are, if you see an aerial application or somebody in the field, chances are it's probably not a pesticide in the first place. So just wanted to kind of point that out so you guys don't panic every time you see somebody out there doing that. We talked about in-hive pesticides such as varroicides, antibiotics, how you use them. So we've covered, I think this slide is number 500 in our 6-week class. So we've covered a lot of stuff. This last week is a lot of information. It gets confusing. It's probably, like I said, no doubt the most important presentation that you'll have for success of beekeeping.